Hello, this is Mr. Higgins. Today we are going to talk about domain and range. Here is their definitions. Please copy those down. Here are some examples using tables and graphs. The domain includes all of the x values, so 3, -1, -6, 1, and 4, were written down in a pair of brackets for the domain. The y values, -4, 7, -8, 11, and 13, were written down in a pair of brackets for the range. Notice they have been written in the form of least to greatest. Over here with this example using the graph, the x value, -2, was placed in the bracket as well as -1, and 1, 2, 3, 4, 5, 6 was placed over here. So all the x values of the 3 points within our graph were placed in a bracket for the domain, and then their corresponding y's, -1, 2, 3, +1, and 1, 2, 3, 4, 5 were placed in the bracket for the range. The mapping is very similar. The one thing we have to remember is that the left bubble is x, the right bubble is y. The arrow always comes out of the x and into the y. Their values in the x value, 3, -2, and 4, were placed in the domain brackets, while the values 0, -1, and -2 were placed in the range bracket. Over here, from the given set of ordered pairs, all the x values, -1, 5, 2.3, and 4, were placed in the bracket for domain, while all the y values, 9, 9, 7, and -2, were placed in the bracket for the range. Now notice we did not repeat 9. Whenever you are identifying the domain and range, you're specifically saying which values were used as a y value, and there's no need to say that 9 was used more than once as long as you specify that it was used. Okay, when we're trying to identify the domain and range, one of the things we always want to do is to start with the minimum value and move towards the maximum. So if we're talking about the domain, we're talking about x's. The x minimum direction is the left, while the maximum direction is the right. So when we're looking at a graph and we're trying to find the domain, we're going to start from the left and identify the value, the very furthest value left, and move our way to the right. If we're looking at the minimum direction for the y, we are going to look at the bottom. We're going to go down. And the y maximum direction is the top. One of the other things we need to take note on are the type of circles for the points that are used. Sometimes there's not always a point indicator saying that it's used, it's just a line, and we just understand that that point was used. But when we have a situation where a point is equal, it will be a solid circle. The symbols that we may use are less than or equal to, or greater than or equal to. If it is not equal, it will be a hollow circle, and the symbol that we will use for that is less than or greater than, without the lines underneath to specify that it is equal. Here we're going to identify the domain of two graphs. These particular graphs have some boundaries on them, and we got to take note of those. One of them has a solid circle, one of them has a hollow circle. Well, the first thing we need to do is start at the very left. So this is the very left of the graph. And then it goes all the way to the 3, which is the very right of the graph, so the minimum to the maximum. And then everything in between is used because this is a solid line and there are no breaks in it. Okay, so we start off with our minimum value, -3. It's the least, so we're going to put a less than sign. Then we're going to put x because we're talking about all the x's used in between. And then we're going to put a less than sign again because it's between all of these. So x is greater than this negative 3 but less than this positive 3. And then the thing we have to come back and consider is that this point was a solid point. So we will put our line under here saying that it can include positive 3. Notice this graph doesn't have any circles, but we've got to understand that just because there's not a circle, it does go all the way to negative 2, and the line itself is using the value of negative 2 for x. And then it goes forever to the right. The reason why this graph goes forever to the right is because of the arrows. The arrows indicate that this graph is going to go on forever in both sections, which means that the domain will go forever and ever and ever, and we say that it approaches infinity. Okay, so the minimum value is negative 2, is less than, and we're still talking about our domain, so it's the x's, talking about left and right, and it goes all the way to infinity. Now the negative 2, the line actually went through that value, so we're going to say it is equal to, but infinity is a special value that no one technically knows the value of it, so we never say that it is equal. We always just use less than or greater than. Okay? Here we're going to identify the range this time. We're going to start with the minimum. The minimum here is negative 8 because that's as low as the graph will go. And it goes all the way up to positive 6. So we got negative 8. Using y's this time because we're talking about up and down. And then we look at 6. Okay. Well, the value for negative 8 is not equal to because it has a hollow, while the value for 6 is equal to because it was solid. Then we can look at this one. It's similar to the second one as on the previous page. The lowest value is going to be way down there at negative infinity. It's going to be way down there at negative infinity because these arrows say this graph goes down forever. And then it goes up, 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 up until this point right here. And even though there's not a circle with a solid point, we still understand that the value of 4 was used on every single point on the line right here. So the minimum value, negative infinity, is less than y is less than 4. And yes, we will write the equal to because the value 4 was used in the graph. One of the other things we need to understand is interval notation. We use parentheses when it is not equal, and we use brackets when it is equal. I would like for you to take a look at these examples and see the translation from inequality to interval form, and then we are going to practice it on the following example. Here we will first identify the domain. We always want to look for that minimum still. This arrow indicates that it's going to go forever to the left, which is negative infinity. And then it goes all the way up to the point of 3. So we're just going to highlight the values that were used on our x-axis, and then write an interval for it. Like we said earlier, infinities are never equal, so we're going to do the minimum negative infinity with a bracket, comma, and then put the maximum value, which was 3. And then we will use a bracket because that point was actually used. The range, very similar. We're going to start off with the minimum. It looks like this could be the minimum, but we've got to remember that this arrow right here indicates that this graph is going to go forever down. And forever down, the negative direction is negative infinity for the y's. And the graph goes up and up and up, all the way up to the value of 2. So the range is very similar. We're going to put our minimum value, negative infinity, and then our maximum value, 2, And then we're going to identify, well, we know if it's infinity, it can never be equal, so we'll use parentheses. But 2, the point was still solid, so we will use the bracket. Be sure to write down any questions you have and be prepared for the following discussion topic, and have a great day.